Welcome back. This is Unit 8. This is now Week 7, Lecture 14. So since the last Lecture 13, you should have done the two POGL activities, the alkane activity and the molecular representation activity. In this lecture, I'm just going to reiterate the things that you learned in those POGL activities. So I'm going to go pretty quickly, and if you still don't get it at the end of this, I have a little couple little practice check yourself exercises at the end of this lecture. Then ask your teacher, send me an email, and we'll provide some more resources for you. All right. So basically, for the alkanes, we can represent any organic chemistry using its molecular or any organic molecule using the molecular formula, the structural formula, or the condensed structural formula. And you ought to be able to very easily go back and forth between these different types of representations. The molecular formula, of course, if you just look at your basic alkanes, and you should know the names of these basic alkanes because we've seen them several times so far this year, but methane, ethane, propane, and butane. Those would be what we consider the molecular formulas of these alkanes. The structural formula is when you show what is connected to what. The Lewis structures, for example, that's when we first started doing Lewis structures, so we could see what is connected to what. And so, of course, that would be the structural formula for methane. You've seen that several times. Ethane, you're showing all of the bonds and what's bound to what. Okay. Propane, same deal, only with 3. And sometimes when you get to where you've got a lot of hydrogens, you just, the sort of short cut way for the structural formula is you'll see chemists just drawing these little lines like this, and that's indicating that there's, H's there, if not otherwise indicated. Sometimes you'll see an organic chemist do that. So that's propane right there. And then, of course, butane with 4 carbons. And each of the carbons is what we call saturated, which means it has as many hydrogens as it can handle, saturated with hydrogen. Carbons tend to form 4 bonds. And so when they're in a string like this, one of the carbons has to be bound to another carbon, but when it's on the end, it's going to have 3 hydrogens, and if it's in the middle, it's going to have 2 hydrogens, and we call that saturated hydrocarbon. All right, and then what's new possibly is the condensed structural formula. For methane, it just looks like, the molecular formula, but for ethane, the way the condensed structural formula, sometimes this is used in text when you want to show really what carbon is connected to what carbon, and the carbon comes first, and whatever is stuck to the carbon comes after that. So in this case, you have the 3 hydrogens right here on this carbon, and then the 3 hydrogens on this carbon. So it's written CH3, CH3. For the condensed structural formula for propane, CH3, because the end carbon has 3 hydrogens, the middle one has 2 hydrogens, and then the last one has 3 hydrogens, would be written like that. And this is when you want to show, what's connected to what. And then for butane, it's just CH3, CH2, CH2, CH3. All right? So that's different. The condensed structural formula is different than the molecular formula. It's sort of a hybrid in between the structural and the molecular formula. Gives you some indication of what's going on with the structure, as well as which atoms are in the compound, but it's written like this if you're like putting it in a line of text or something like that. You need to save space.